Hi, everyone.
Hi guys, everyone's connecting to audio.
Aksa, are you on mute?
Hi, no, like there was one participant, Malvika, who's still connecting to audio. I was just waiting for her.
Cool. I was just testing. Yeah.
We're live on YouTube now.
Okay. So, hi guys, welcome to day 5 of WiDS Datathon workshop. So, just a background of WiDS Mumbai. We started back our first conference in 2018. Like it was quite huge in VJTI, and we had a lot of turnout. And now this is the 4th year of us doing these conferences. But apart from that, this year we have also started a Datathon workshop, which is in preparation for the WiDS Global Datathon. So if you have not registered for the Datathon yet, please go to the website and register. We'll be sharing a link as well in case you haven't registered. So like we have been having the Datathon workshop since the past 2 weeks, and today is the final day. And we have Karthika over here who will be sharing a small intro to deep learning, and she'll also be going through the last year's Datathon workshop, Datathon competition, like what all problems were there and how you can approach those. So hopefully that will be very helpful in solving these problems for this year's Datathon. So yeah, hope you all can get some good information to take back home with you all today. Okay, we are already at home, so yeah, keep in your home today. So yeah, over to Karthika. Yeah.
Thank you, Aksa. I hope you all can hear me clearly. I'll start presenting my screen. Thank you for joining in.
Sorry to interrupt. Just one thing. In case you'll have any questions, please post them in our chat, and Karthika will answer them. Yeah.
Yes, I will. I'll take pauses in between, and we can have all the questions at that time. Uh, okay. So what I'm going to do is initial 30 minutes I will spend on a bit of neural networks, and so this part is not really needed for solving this year's problem statement, the Datathon problem statement, but it's a good to know thing. And I think in 2019 problem statement, neural networks were used because the data set were image data set. So what if next year's data set is also something where you require this kind of knowledge? So I just thought, let me just tick it off. Let me cover this concept as well. So let's dive right in. You're able to see the screen, right?
Yes, we're able to see the screen.
Okay. Let me share this link in the group as well, in the chat. Okay, so you can, I hope you can see the, like, you can also have it open in your own, at your end. But okay, anyway. So yeah, so what is deep learning? First of all, let's go and understand the building block of this, which is the neuron. We all know that in our brains, we have neurons in the nervous system that really help understand or decipher anything around in our external world. So how does these neurons actually work? They capture the external signals using these dendrites, and then the output is given through these axons. Okay, so it's a simple input output system, but what goes inside the system, how the transformation and everything is done, is the crux of it. So what we are doing artificially is we are trying to replicate how the neurons work. And then we have this perceptron, which is the artificial neuron. So what is like, it's again a simple system. There are set of inputs and you have an output. And let's say it is a binary system that the output can take only values 0 or 1. So given these set of inputs, like here we have 3 inputs, uh, and for each of the inputs, there will be some weight associated with it. And we can also have a bias. So what is going to happen is the equation is like this. X1 into its associated weight, which is W1, plus X2 into W2, plus X3 into W3, plus the bias term that is assigned that is called as B. So this thing, whatever this resultant value that we get, that can be put into some activation function. Now, let's forget the term activation function. Let's just consider that the output that we get from here, if it is greater than 0, then we are considering the y to be equal to 1. And if it is less than 0, then we are considering the y to be equal to 0, the final output. Okay, so this is the kind of rule that we have set. So let me explain this again. The output y is going to be equal to 0 if summation of these wixi is less than or equal to threshold, which we have set as 0, and is 1 if the summation is greater than the threshold. So this is a simple artificial neuron which we have developed. Simple function. So given the input, it can produce a particular output. Now, the task here is to actually understand what are the values of these weights and these biases. Like that is the learning part. How can we make the neuron learn what the weights or biases should be so that the output that is produced is the desired output? So first of all, let's take an example. You know what an AND gate is, right? The AND logic. So same way NAND logic is not of AND. So basically what NAND gate is, when both the inputs x1 and x2 are 0, 0, then the output should be equal to 1. And for the rest of the cases, the output should be equal to 0, right? So we want to build this kind of a neuron. How do we do that? So we have just 2 inputs, so we can do some trial and error and find the values of these weights and biases. So this is one of the combination that both the weights can take the value as -2 and the bias can take the value as 3. So now when both the inputs x1 and x2 are 0, 0, we get 0 into -2 plus 0 into -2 plus 3, which is 3, which is positive. And our threshold is at 0. So our output, which is the final output, y, is going to be equal to 1. And that is what we want. So it is following the NAND logic, right? And any other combination like 0, 1, if you see the output is going to be negative, and because of the threshold set at 0, the y value is going to be 0. And that is following the NAND logic, right? So this way we have coded a simple neuron, which is able to replicate the NAND logic. So the main task here was to understand what the bias and weight terms, the values are going to be, right? So that is a learning part. Now, like I told this activation function, I introduced that term and I told you to keep it aside. Let me go back to the term now. So when I talk about threshold, I'm setting it at 0. This is like a step function, right? When I say it is greater than 0, then the value is going to be 1. And for the values which are like the resultant value to be when it is coming negative, then I'm setting it as 0, right? So that is a step function. Instead of a step, so what I did essentially was I used an activation function, which is a step function. So this combination of wixi plus the bias, the answer that I get, I put into the activation function, and then finally I get the resultant output. And also just to let you know, the summation of wixi can also be written as a dot product between w and x. So because what dot product is essentially, like let's say there are 2 vectors, xi plus xj and wi plus wj. So the dot product between these two is nothing but the summation, that is xi into wi plus xj into wj, right? So we can write it as a dot product as well. So that is why I've written the equation essentially became w dot x plus b. So this is what we compare with the threshold. Okay, coming back here. So this is one activation function, step function, but we don't generally use this. I just use this activation function to explain you how this works. Because in real world, if you see, everything is non-linear. This is a linear function, right? Everything is non-linear. So we need a non-linear activation function. And that is why we can use a sigmoid as our activation. But this function that you see, it's called a sigmoid. There are multiple other activation functions like ReLU, tanh, and everything that you can use. But let me talk about why these kind of nonlinear functions are important, because here you see there is like comparing with this. Now there is, if you go from this level to this level, there's a sharp increase in the y-axis, right? It directly jumps to the next level. But in this case, if you go from this level to this level, there's only a small increase in y-axis also. So a small change in x-axis or the input is resulting in a small change in the output. So this gives the model the ability or capacity to learn. If it's suddenly changing, it's not able to learn, right? So this region, this part from here to here, this is the area where it can learn. So that is why it's important we use such functions in an activation function. So that introduces the learning part, the machine learning part. And that way we can learn the weights, what the ideal weights and bias could be. Okay, now let me give an example. There's a very layman or high overview explanation of how this learning happens. I'm not going to the maths of it. So I talked about just one neuron now, or one perceptron now, right? So what neural network is basically, in one layer, you can have multiple neurons, and that way you can have multiple layers. And the deeper you go, it becomes like the deep network, right? So hence the term deep learning. So, so now you have this neural network that you've built with multiple neurons in one layer and multiple layers, and each of them will be having their associated weights and biases. The task here is we have to learn these weights and biases. How do we do it? Let's say for the first time, we randomly assign some values for all these weights and biases. We give the input and we calculate, with a combination of these weights and biases, we calculate what the value will be, and then we put in the activation function, we get the output, we propagate that to the next layer, do the same, and so till the output layer, where we finally get the output. Now that output, we will compare with the actual output and see what the loss will, what is the difference, the loss. That loss is what we have to propagate, and that is the backward propagation that we do. And at each time, we are correcting the weights and bias values. So all this is done. So this backward propagation, algorithm, gradient descent algorithm, these are all something which you have to go in deeper understanding, if you have to really understand the maths behind how this learning is happening. Okay, and that's very useful. So sometimes in interviews and everything, these questions are actually asked. I have been asked to explain backpropagation algorithm and gradient descent algorithm, but I'm not taking it up here because it requires calculus as a prerequisite, because and I would highly recommend you go on your own, and there are tons of resources. So go and learn it, but I give you an overview of it. And in case you want me to take a separate session on understanding the maths behind it, let me know. I can take a separate session for that. So that is about, I hope this gives you an overview of what neural networks are and how it functions and everything. Now let's go into coding a neural network. Here I've taken a very simple problem statement that is, I want my neural network to learn the sine function. Which this sine function that you see, this graph, this function, I want my neural network to learn this function. So my inputs are basically, I've taken 5,000 random values in the range 2 pi, which are these x values, random x values I've taken. And my output, that y, the desired output y, is basically the associated, like for every x value, I want the associated y value, which follows the sine graph or the sine curve. Okay. So I have, for y, I've directly used the numpy sine function. I plotted this. Now, how do I make the neural network learn the sine function? Like, I know, I mean, this is something which you will not be using anywhere because we have sine, like sine, NumPy already has a sine function, but this is just for the learning, like understanding sake that I've taken this problem statement. So how we do is, we can use this Keras library, and from that we'll import sequential and these dense and activation layers as well. So why I have to call the sequential API is here is because like you saw, the neural network is like you have one layer and then you have another layer, so it's like a sequence, right? So we'll be using a sequential API, and then we'll it's very easy. It's like sequence. You'll have to just define all your layers. So what I've done is the first layer is just so these layers are called dense, okay? And I've in the first layer I just have one neuron because I have only one input, that is just x, that is one particular number, right? So there's only one input, so one uh, sigmoid is, or one neuron is only there in the first input layer. Dimension is one, and I've used ReLU as an activation function. And the second layer, I have 25 neurons. Likewise, I like have 3 layers in between, and then the final layer, again, there's only one output neuron because I just have one output over here. Why? So this way, my neural network architecture is ready. So here you can basically do a lot of trial and error, see how many neurons you can have in each layer, how many layers you want to have, which activation function will work good, and so and so. And after that, it's also important at the time of compiling this network. It is important to define what your loss function is going to be and what your optimizer is. By loss, I mean the when you take the difference between the actual output and the predicted output. That time, that loss. How do you want to define that loss? Like, do you want to do it through mean square error or some other way? So that you have to define over here. And then optimizer is basically the learning algorithm. How is the model optimizing the weights and the values for weights and biases? So there are different things, but for such problem statement, Adam is the one you can definitely go for. After compiling, you have to fit the model. So when you fit, you provide the set of the training data, that is the X here, and then you also provide the desired output, which is Y. This is a supervised learning. If you remember, this concept was introduced to you in the second session, what supervised learning is. So X and Y, and then you can also define your epochs. Epochs is basically how many iterations are you going to do. Again, one iteration, like you go one forward and then one backward. That is not enough for the neural network to actually understand what are the good values for weights and biases, right? So it needs to have multiple iterations, and then only it will slowly learn. So you have to define that. And if you can also do in batches, like you can do in 20 different batches. Like we have 5,000 inputs, right? So we can take batches and then do. And also, before you do this, one way is you can use train test split function, which is there in sklearn, and you can split the input, or at this point itself you can just specify the validation split as 0.2. So here itself it will split the data set. So this is the way, and finally this way the model has trained, or it has learned everything, the weights and bias values. Now we have to test it. So we will generate another set of testing data set, X test. Randomly we'll take 25 data points in the range of 2 pi. And now here, instead of using this NumPy's already provided Sine X function, let's use the network that we built, network.predict, and put the X test in this. And now let's see what the values these YPred are. So when we plot it, we see this. So now it has learned the sine function. It is following the sine function, right? The outputs are in the sine curve kind of a format. But now I have a question for you here, that do you think this model is a good model? Like, is it really good? I know the output is this. I have a poll over here. If you can, like, I'll launch this poll. Let me know, what do you think? Is this model a good model or not? I'll give like 20 to 30 seconds for this.
Can we click on this?
Yeah. Are you seeing a poll coming up on your screen?
Yeah,
Yes.
we can see the poll. The thing is, I have a question. Like, how do we know if it is even good or bad? What are the criterias? Do you think of? How do we think?
Yeah,
And
I will answer that, but just based on now, like your intuition, I just want to know what your answer is. I'm just going to answer that.
We wanted a sign, I think. Yeah.
Yeah, okay. Should I end the poll? I'm ending it in 5, 4, 3, 2, 1. Okay. So I got like a 50-50 kind of answers for this. So what I feel is, so what I want to tell you here is, doesn't it look like it's overfitting? Like there's no error at all. It has just learned the sine curve so nicely that it's like overfitting, isn't it? Now it is just in the range 2 pi. What if I'm giving the value which is outside this range? And will it again understand what the sine, like to follow the sine curve? Because sine curve, if we continue this curve, it should continue like this, right? So that is the problem here. So here, what has happened is it has overfit. Like it has learned the sine curve in this particular range well. But I'm not sure about what it will do if the x input that I'm giving is outside this range, right? So what things that you can do to tackle this overfit kind of a problem is, I'm not going into details of what overfitting is. I hope that was covered in the last session or last session. But so why, like the things that you can do to overcome that in this particular problem statement is by maybe you can add noise in your input data set. Or you can also use dropout layers. So there are something called dropout layers, which randomly, shuts put one particular neuron in some layer, so that in the second iteration, it's not like in the first iteration it has learned some kind of a path, right? In the second iteration, because one of the neuron is shut, it has to find its another route of learning. So that way it keeps on. So basically, there's another thing called just dropout layer. There's like you have dense layer, there's dropout layer that you can use, and then there is regularization. There like L1, L2, all these terms were introduced to you in the last session, I believe. And then or maybe you can sample it. So there are multiple ways, hyperparameter tuning, all these you can use to tackle overfitting. So here what I'm doing is I'm going to add noise to the input data. So I have a random noise, I'm adding that. And then when I plot, this is the input data that now I have. So the black line that you see, that is the actual sine function. And the other things, the other dots that you see, that is my data that I have. So now this data is not exactly a sine curve, but it is following the sine curve. So it is like, I've introduced few noise in this. Now again, with this data set, I will build this architecture, and then I'll fit, and then I'll have another set of test data set. And now you can see this is what I've got. So orange is the test, the output that I'm getting from the test data. So it has learned here. And now that you can see over here, there are like few dots which are not exactly following the sine curve. So there is this that actually allows this model to the ability to learn more, right? So learning is important over here. It's not that you have to get it right. If you get it right in the first go, then there's no scope of learning anymore, right? So learning is important over here. And so this is the idea. But this was a very basic problem statement. I just took it so that you get these few concepts right. If I had taken some complicated concepts, I wouldn't have been able to explain these small nuances. But now let's go on to convolutional neural network, which was used in the 2019 Datathon problem statement, because the data set that time was image data. So in convolutional neural network, what happens is this convolutional part is the important thing. What neural network is what I've already explained to you. So let's say we have image data. So this is used specifically for image data set, okay? Let's say it's 4K Ultra HD. So we'll have these many pixels, this into this into this. So that is total of this many pixels. It's a 3D image. And it's an RGB, so that's why 3. Okay, now different neurons connected to each other in the first. So basically, if you we have these many pixels, for each pixel we will have one particular neuron. So you can imagine the first layer we have these many neurons, because one neuron cannot take in two different things, right? Like 2 pixels cannot go into one. So each pixel will have one neuron. So we have these many neurons. So isn't it a huge thing? How, like, this is the problem. You're realizing the problem over here, right? When you're dealing with image data set. So the normal regular neural networks that we have seen really, I won't say fails, but it's very difficult to work with that. So that is why this convolutional layer comes. What we do is, so this is the image, the green bigger one. We'll take a filter, like the yellow one that you see, and we'll convolve, or we'll go over this image, and we'll calculate the value. So basically what it's doing is, let's say we have a picture of a tree, and we have taken a upper section of it. All of that is going to be green color only, right? So we don't need the entire part. We can just take a small section of it and keep it here. So basically, for every 3x3 segment, we are taking one representative pixel and taking it ahead, like that. So that is what is convolutional doing. So basically, it's reducing the dimension. And that is very important over here. After convolutional layer, we use a pooling layer. Pooling can be max pooling, average pooling, so and so. So what max pooling is, for example, is like this is the result here after convolution. For this 2x2, we'll take the maximum value and then put it ahead. So again, basically here the dimension is reduced, and we've just gone with maximum values. And finally, so this we can have series of convolutional max pooling like this, and then finally we can finally give it to a fully connected layer, which is the neural network, normal one. So this is, in summary, this is what is happening. So we have, like, for example, a car image, and then we'll take and convolve it, and then we'll have pooling, same way, multiple times, and then we'll finally flatten it, and then we can give it to the actual neural network, and then it can predict. Like here, what it's going to do is it will predict the probability that it's a car, and then probability that it's a truck. So basically, what the ideal output here could be 90% it's car and 10% maybe it's truck. So something like that. Okay, so let's take an example of this CNN problem also. So there is this very basic image dataset called WiDS dataset, which is, you don't have to go anywhere for this dataset. It's already there in the Keras thing. You just have to call datasets.mns.load data, and it will load the MNIS data. What it is basically, these are all numbers. So you're just trying to identify in that image what number is present in that image. So this is one example. This is one of the image. We'll have to do some rescaling, reshaping, and everything, because Keras. So you have to give in 3 values. So I mean, so we'll have to reshape that. That is important. We have to reshape in an array to 4 dimensions. So this is a 3 cross. This is just 2x2, and it's grayscale. So we don't have that RGB 3 thing. So that is why it is just 28x28 pixel and 1, because there's only 1, like grayscale it is. And we'll have to reshape it into 4 dimensions, because Keras takes only 4 dimensions. It's just, I mean, it's nothing. It's just a way to do it, because Keras needs that kind of a dimension. So that is there. And then after that, what you do is, again, like I told, in Keras, there, for everything you have particular layer already there. There's this dense that we used earlier. Then same way for convolutional layer that I introduced you to, Con2D, dropout layer, like I had mentioned earlier, flatten, max pooling, all these layers are already there. So you just have to call that function and put in your parameters, and you can build your architecture. It's very simple. It's just this much. All the concepts are just in these few lines. Okay, so that's there, and then you can compile. And okay, these sparse categorical cross entropy here, what I mean, so mean square error is what we use there, right? Here, it's a categorical thing, right? You're just predicting, is it a car or not? So it's a category, right? So that's why we are using this categorical loss. And then we have to fit, and when you evaluate, and then I'm just going a little fast over here. So finally, you give your test data set, and then it can predict. So this is the test image I've given, and it does predict it correctly. It's 9. Argmax is what? Okay, so what it's actually going to do is in the output, because we have 9 different outputs available over here, from 0 to, sorry, 10 different, 0 to 9, we have 10 different outputs available, right? So what it's going to do is in the output layer for from each of the neuron, what you're going to get is a probability value that, okay, the first neuron is going to tell you the probability that it is 0. Second neuron is going to tell you the probability that it is 1. So same way, that is going to, like, each of the neurons are going to give its probability. Now, for this image, what is ideally going to happen is the neuron that predicts 9 is going to give the maximum probability, and the others are going to be very small values. So that is why you have to take the maximum out of all these outputs. That is what argmax is doing, and that is what you're getting as the output. Like you want that as the output. So go through this, and there are a few resources also attached. I hope this is going to help you. This is very basic, just to emphasize on few concepts that are really needed to understand the complex part of this. And so I'm not sure if I should take this up now. I'll keep this for end because I want to cover the other part, which is more important right now. But this was a WiDS Datathon 2019 a problem statement where the images were satellite images, and the problem statement was you have to predict in that particular satellite image if oil palm plantation is present or not. So that was it. It was a labeled data set. So we had to, I had participated in that datathon, and I used convolutional neural networks. It was an unbalanced data set. So I had to use the idea of downsampling and upsampling and all of that. And I mean, I'm just not spending you. I have linked this particular course, so you can take your time and go through it. Just one thing I can introduce over here is these architectures that you see. If it's a complex problem or something, building that architecture, neural network architecture, can be very challenging. So, which is where we use transfer learning. Just trying to find that part of the code. So much. Yeah. So BGG, so there are different architectures pre-defined, like that. It's there in Keras. So there was a competition long back, and people had participated in that, and then that time they built their own architectures. So what if you want to do, like, go over these problems, one really good way is use those architectures which are already there, and use that, because the initial layers of any convolutional neural network is basically doing the same thing. It's trying to understand the basic, like detecting edges in the image or some sort of, those things only. So initial layers are all learning the same thing. So you can use transfer learning, like you can use an existing architecture which is there. People have open sourced it. You can use that architecture, and the final layers you can freeze the final layers, and you can add your own final layers so that it is catering to your problem statement. So this is one thing you can do, which I had done. But yeah, these are the two things that I wanted to just highlight in this particular thing. Now I can go on to the next part. I'll take a pause here. If you have any questions, let me know.
We have a question in the chat section.
Yeah.
Yeah, you can ask.
I have a question. Hi, my name is Ramakant. I wanted to understand, like, how do you, can you just show that particular page where you had that program?
This one?
Yeah, this particular, yes. So my question to you is, like, See, I'm a total beginner in data science. Okay, so my understanding is like I want to know how do you think, what are the steps that I need to do to get through this from right from the problem statement till the solution. How do you know what are the steps that you need to do right from collection of data, then cleaning it and doing it, and how do you get the steps? How will you know what to do next?
Okay, yeah. So there is nothing which is predefined that there's, this after this, go for this step or something. But
Uh-huh.
what the approach is, you have the data set, then you
Okay.
have to study the data set. Like I'll tell you, 90% of your work is that studying what your data set is actually.
Mm.
See, understanding the missing values in it. And if it's an image data, obviously image is not going to have missing values, but it's like you have to pre-process that. I mean, like if it's a RGB, you might want to grayscale it or apply some kind of filter to it or something like that. So you have to reduce noise from the image or something like that. So pre-processing and studying the data set, understanding the data set is important, because you can't blindly give the data to the model, uh, because and if you do that, you can't interpret the results. So it's very important that you understand what the data set is. So that is like 90% of your work. So when people say data science and all these things, the harsh reality is modeling part comes towards the end. The initial part is understanding the data. Like here in these problem statements, the data is pretty like direct, it's given to you. So that is why you won't spend much time in understanding the data. But generally, if you're starting from scratch, that is going to take a lot of time. After
Okay.
which only modeling part is going to come. And modeling is like, thanks to all these libraries, is just a matter of few lines. So you just have like all these decision tree if you're using or using any kind of thing, it's just they're already, you just have to call that function and dot fit. That's the simple like 2-3 lines is what is modeling going to do. Understanding data part is the important thing. So once you've understood the data, uh, when I say understanding the data, you have to also understand, do you want to go ahead with these features, or do you want to like you think these features are unnecessary, you want to remove those features, it won't contribute to your learning of the model. So all that also comes there, like that the correlation, that concept that was introduced to you by Julian in the second workshop, all that comes here. The EDA part is important. So when I'm saying understand the data, EDA is what you have to do.
Okay.
Yeah, so after that you get your model, and then the evaluation part comes, where you have to see what metric you want, and based on your client, or what the problem statement is, are you okay with 80% accuracy? If it's a medical problem, then 80% is so low, you have to have good accuracy. So all these things comes there.
Okay.
So the idea is, it's very simple that way. You get your data, you have to understand data well, and then you have to decide which algorithm you want to go ahead with, and then you have to also define your metric. But this is in summary, but each of these things require a lot of work.
Yes, that's the struggling thing that I'm going through right now. So I wanted to know how do you have the flow of thoughts. So that's good information that you've given. Thanks.
Yeah.
Wanted to
Yeah.
add one thing, like you can go to our YouTube channel and get all the old sessions in case you have missed any of them, or if you want to revisit them to get a better understanding. So you can just go to our YouTube channel. Like we also have some really nice session that we had from last year's conference, like last year's, which was virtual. So that's why you have all the videos available. So you can go through that and get a better understanding.
Yeah, different people who are working in
Okay.
different domains, they have talked about how they're using machine learning in their particular domain. So you can have a look at those videos as well.
Sure. Thank you.
Thank you for your question. Are there any more questions at this point? If no, let me proceed. So now what I'm going to do here is, I'm not going to introduce any new concept over here. It's going to be the things that you've learned in the past 4 sessions. But the idea here is, I'm trying to, like in the past 4 sessions, you learned different things discretely, right? So I'm just trying to combine all those 4 things and project you over here. So it's like a summary, you can call it. And I've used the data set, the 2020 data set, which is the last year's WiDS Datathon data set. Why I used it? Because this year's data set is also very, very similar to last year's data set. So if you go through this, you'll get the confidence. Okay, now I can start working in 2021 data set as well, because they're very similar. So let's see how to approach this year's Datathon problem statement. Okay, so last year's problem statement was again, whenever a patient is moved to ICU, it suggests that the patient's health can rapidly deteriorate and like whatever. The idea was to see if the patient will survive or not. This year, again, the data set is same, but the idea here is to understand if the patient has a particular type of diabetes or not. So you see, it's again a binary problem statement, 0 or 1. And just the target variable has changed. Last year it was prediction of death, which is what I'm going to take up now. And this year it's predicting if the person is having some kind of a diabetes or not. Okay, so what you're going to do is, first of all, you'll import all your libraries, okay, and then you'll import the data set. So we have training data set and test data set. Training is labeled and test is the unlabeled data set. We will visualize both of them, like, sorry, not visualize. We'll just like see what the data set is like, head, and train is this. So yeah, so this is hospital death. This is a target variable. This is what you have to predict here. So in the unlabeled data set, you see this hospital death is all NAN. So this particular value is missing, which is what you have to predict. And in the training, we have these values as well. And if you see the shape, there are like 186 columns and these many rows. So these many patient data set are there. And there are, for each of the patient, there are 186 different attributes or variables present. So don't you think 186 is like a huge number? So how do you study these different columns and everything? So that is a challenge. And it's, I mean, if there's a way that you can reduce this number, like understanding that, okay, this column is probably not needed, so you can just remove it or something like that, then that will help you also, because your model will also learn, I mean, needn't learn all these columns, because if you are redundant, it's good to just remove it at the beginning itself. So that is the EDA part. And like if there's something in some things here that you're not understanding, I will highly recommend you go back, revisit the second workshop, or you can also go and check out, there are other tons of resources as well. But these concepts were covered, the EDA part is there. I'll go to the approach, how to approach this thing. So first of all, we'll see if this data set has null values or missing values or not. So this way, when I do is null is the function that I'm calling. And what I'm getting to see here is for each of the column, like these are different column value names, okay? For each of the column, how many missing values are there? So you see these columns have like 84,000 missing values. There's like huge number. Okay, and I think the total number of data present was only 91.7K. So you see, majority of the values in this particular column is missing. So one very easy thing is, if the column is having like lot of missing values, just remove the column. But we are not taking the call, or we are not taking that call yet. We are still learning or understanding the data set over here. So that is there. And then there are a few columns which have only in hundreds. So probably here you can do imputation. That is, you can substitute these missing values with some highly likely possible values, like a mean in case the column is numerical, or if it's categorical, then you can impute using mode, something like that. Okay, and then this describe will make you understand, like you can get the distribution in this particular data set for each of the column. So you see all these things. There was one particular column I saw, which is this one, readmission status. This has all things 0, which means that this column entirely is just having 0 value. So what's the point? If for all the patient those values 0, then there's nothing unique in this. So variance is important. Like the more diverse the values are, there's a scope of learning or distinguishing things, right? If everything is same, then there's no point. So this right away you can remove this particular column. So that is there. And then, so this, what exploratory data, also there's another thing we can do is you can see the target variable count. So a target variable here is hospital data, death. So value counts will give you how many values, different values are there in this particular, and what is the count or frequency of it. So there are only two different values. It's a binary problem statement, 0 and 1, and 0 values are these many and 1 are only these. So this is an unbalanced data set. So generally in medical area, you will find unbalanced data set itself. So this is also a medical problem statement. So it was like known that it's going to be an unbalanced data set, but there are ways to treat unbalanced data set, or else you think you can deal, I mean, you can go ahead with this much imbalance, then also it's okay. So how to deal with unbalance, I'll just tell quickly. Maybe you can upsample, or you can, reduce these zero values, randomly pick few values or something like that. But in this particular problem statement, it's not really necessary. I can tell you that you can go ahead with this unbalanced, because the metric that we'll be using will take care of the unbalanced data set. I'll come to that point anyway. So now let's do the EDA. So this approach of EDA, or this particular thing that I've done, I have not sat and coded everything. I have taken it from this particular kernel. They had submitted it last year. I found this as to be the best approach for EDA, and if from learning point of view, like if you want to learn how to do it, go through this, because this really tells you how to do it. So this datathon, they are giving you dictionary. So data dictionary is what? So now we see 186 column. If they don't provide a dictionary, it's very hard for you to go and read the name of each of the column and then Googling it and understand what this actually, because all these medical terms you don't really know, right? These columns, different columns, like I have no idea what these columns actually mean, right? So that is why dictionary is very important. And even if you're working and you have any particular data set, then it's very important to first create a dictionary before passing on to the other person who is working on modeling or something. So data dictionary is very important. So this dictionary, I'm reading this dictionary and I'm seeing here. So what I can see here is this category, and then there's a variable name and units, data type, and then the description. The description is important. So what category here means is it's good that they have done this. So it eases your problem. Also, what they have done is the different variables that are present, they have grouped them into one particular category. Like identifier means all these IDs, hospital ID, patient ID, all these are identifiers. These can be grouped into, like these three variables can be grouped into identifier category. And then demographic is your age, gender, and all these things. So that can be grouped into demographic category. So you can category wise, you can analyze the different variables. Like at one go, you don't have to take 186 variables and analyze. You can filter it out. Like let me first analyze the demographic variables, and then that way you can build it up. So, and you can also see in each of the categories how many different variables are there. Again, value count, you can do that. And then you see for like labs, there's a category called labs. 60 variables are there in labs. So all the lab results, there are different variables for that. And same way, like you can see over here. So what the approach I would also like you to do for this year's problem statement is go see the dictionary and see what are the different categories present. For each of the category, analyze the different variables separately. And let's start that process now. I won't go through all the categories. I'll just pick few because I don't have time and I want you guys to take your own time on this particular thing. So, for example, first category, we're starting from bottom up. So this one, causes, example, prediction. It has only one variable. So we take this. I mean, these, I'm not going into the code, okay? I think when you get to, okay, let me share this. I don't know, share. Okay, so it's just like df.category. Category is a column, and then return. So this is a function that defines, so we can just use that function directly. We put the dictionary, which is the data frame name, and we call the particular, we write the name of the column the category we want. And that way we'll see in this particular thing, we have only one column. But here is a funny thing that this particular prediction, this variable, this column was actually not present in the training data set. So this column was not present, but it was there in the dictionary. So these things can also happen. So you have to cross check if that is there or not. So that's one thing. And then the next category was Apache grouping. So we're going Apache grouping. It has two variables. Yeah. So the two variables are these three. There's this 3J body system and there's a 2 body system. Now here is what your research part comes in. Like Rinki was also emphasizing in the last session that research is important. Any domain, you have to research that. So here, obviously, these two terms, we don't understand that. And the description is this, that admission diagnosis group for Apache 3 and this for Apache 2. Do we know anything about these things? If we don't, then what we can do is we can Google and we can research and we can understand. So for this person, when this person did that, what this person understood is that both these things, Apache 2 and 3, are kind of same thing. It gives a similar score, but Apache 3 is better. So let's just go ahead with one of these variables. It's not necessary that we go ahead with both of them. So this person just took the 3 one and dropped this particular column. So this way we reduced that column count as well. So like this Datathon also has, like after the Datathon, there's some research paper part of this. Okay, there's an extension of this Datathon. That is where you can highlight all these research or insights that you have developed. Okay, so that research paper, like go through the website, you'll understand what I'm talking about, the research part. So not just a Datathon, you can also emphasize if you came up with any unique research out of these things. Okay, or unique approach that you have followed or something. Even if you have not, feel free to actually write a research paper on it, because why not? I mean, that is also another learning. And then, so that is that. I'm just going like highlighting few things. I'm not going in depth. I want, like, you can, this notebook is there with you. You can spend time on it. The next group is prediction. So it has again 2 variables in this. And then these also can, like, you can go and read the description for each of them. You can understand. And what here we can see is that 2 columns in this above category provide information about the mortality of a patient. And again, we can expect some correlation for both the columns. So when both the columns are giving you a similar kind of an outcome that is predicting the mortality, that means there could be some correlation between both these columns as well. So we can do that heat map, if you remember, or if you can recall this from the second session, the heat map thing. So heat map gives us 0.88. So there's like high correlation between these 2 variables. So clearly you can go ahead with one variable and you can drop the other one. And which variable to go ahead with is again your research or your call. So here, what we can do is, because we are predicting the ICU survival rate here, so we can drop the hospital death probability and we can go ahead with ICU death. So that's like, it comes from the domain. This call comes from the domain, or the problem statement that we are trying to focus on. So all these are the innovation part that you can do, okay? And then identifier. So here you can see that there are like 3 identifiers, and these encounter ID and patient ID are unique. So for each of the variable, it's a separate ID. So basically, it's not giving you any information. So you can discard that at the time of training. But hospital ID is like multiple patients can have a similar hospital ID. So you can keep that variable, because it is possible that one particular hospital is responsible for more ICU data, something like it, that is possible. So that can be some kind of a relation or correlation. So we can keep that particular ID, but the other IDs are unique. It's just identifier. So that is, you can drop those from learning. And then same with this, has like these, this particular grouping has a lot of variables in this, and But here what you see is each of the variables are actually telling you what kind of disease it could be. So it's a different diseases. So your call. I mean, do you want to keep all the variables here or not? Because I feel these are different diseases. So let's just keep all the variables and not drop any of them, because probably these are all communicating different things. And then there's labs, which have like really many variables. There's D1 something something, then H1 something something. So you can go to the description, and what you can do is you can plot the heat map again, the correlation map. So, and you can see if variables are highly correlated or not. So for example, let's see this 0.91, which means it's highly correlated. This H1 something, and it's highly correlated with D1 something. Let's pick another. So this one, 0.85 is also highly correlated. This H1 something, and then there is this, what is this? D1. So like with just two examples also, and you can see other examples also, what you can observe here is there's some high correlation between H means hourly and D means daily. Is there in the description. So there's high correlation between hourly variables and daily variables. So you can probably go with one. So your call. Now, if you feel like you hourly contributes more information, like it's coming hourly, so you can keep the hourly variables and drop all the daily variables. That is one thing you can do over here. Then you can analyze the demographic. So demographic have all these ethnicity, age, and everything. So each of these things you can analyze separately, because they tell you different, like like for example here, this is what hospital death. So this is the target variable. We saw it was unbalanced. We have a lot of zeros and few ones only. Then there is age. You can plot a histogram. So in plotting histogram in Seaborn is basically a dist plot. This will plot a histogram. So you can see a lot of people are in this age group, from 60 to 80 kind of a age group. Then there is BMI. So basically go to this notebook, try understanding it. If you have any doubts, reach out. It's okay. And yeah, here let me emphasize on the feature engineering part, which Rinki had mentioned to you in the workshop number 4. That was so here there's BMI, and what you're doing is you're comparing BMI with the target variable. So everything, when I'm talking about correlation here, analyzing one-to-one correlation, you're seeing with respect to the target variable. So target variable here is the hospital death, and you're seeing how it is related with BMI. So for hospital death 0, you're taking all the 0 hospital, like wherever the hospital death was 0, like there were no hospital deaths. So you're taking just those variables, and for them you're saying BMI, what is the distribution of their BMI, those patients' BMI. And then same way you're taking the ones who died, like the one hospital death, and comparing their BMI. So both of them actually are following the same pattern. Okay, so so because both of them are following the same pattern, what you can tell here is that it's not actually telling what I'm trying to say here is it's not contributing to the any information, right? When both the categories are giving the same thing, there's no difference in between both of them. So then you can't actually understand anything more than this, right? I mean, if there was some difference, like, okay, if the ones who are 0 were following some other curve, and the ones who are following 1 are following some other distribution, then you can say, okay, if they're having this particular BMI, then there is high chance that they'll die or something like that. But when both of them are same, then you can't really predict that. So you can drop this column, or you can also go a little deeper. You can actually do feature engineering, which Rinki was telling. Like this values, the BMI values, you can classify it into your own understanding of underweight, normal, and overweight, or obese, or something like that. And like this way, you can classify that. Basically, this numerical value, you're converting it into categorical. And then you are so seeing the value counts for each of the categories, how many are there. So now you see that obese are lot many. Obviously, I mean, we saw that graph is also peaking towards these values. So this is a distribution. Now this distribution, you can compare it with hospital death. So what we observe here is that BMS itself was not having any major effect, but as soon as we converted it into categories, we can see that some categories like underweight, like this underweight, have large ratio of hospital deaths and thus would be better choice than BMI. So just a minute. Yeah. So if you see the category wise, here we can see some kind of a correlation. Like, okay, people who are more fall into this category of underweight, they have high proportion of people who will die. So when you just saw simply the BMIs, that time you couldn't come up with this insight. So feature engineering is important. Just I'm emphasizing on the idea of why feature engineering is important, because here you can see now, here you can develop some kind of a correlation. Same way you can do for other variables as well. It's pretty much similar thing. This plot basically is a cat plot. Okay, it's a categorical. It's there in SNS or Seaborn, and cat plot is a new addition to Seaborn, which helps you directly and use it for categorical variables. Categorical variables like these, female, male, or something like that. So not numerical, categorical variables. And you can define what kind of plot you want. So it's bar, if you define here, then you can see it in the form of bar graph. Okay. That is that. And then for each of the demographic variable, they're separately analyzed. So you can imagine how much time EDA takes, right? It's like the major part. If you've done this part, then the modeling part is like just a day or two. So for each of the variable, you can analyze. This is nicely take your whole weekend. Box plot. Remember, these kind of all plots were introduced to you in the second workshop. And if the correlation that you're seeing is very large, like so many variables are there and you're not able to interpret, so you can zoom in and do that. Was also taught to you by Julian how to do that. So go through this. I'm just scrolling because the concepts that I want to introduce you, I have covered that. So that is it. Now, next part is data pre-processing. After you understood that what variables are redundant and you can drop those variables. So this way you have reduced. So what has happened over here is we've reduced it to 128. So 186 we have reduced it to 128. We have dropped about how many? I think around 59 columns. Yeah. So now the next part is data pre-processing. That is, we have to treat missing values. So this data set has a lot of missing values like we saw already. That's one thing. And also these categorical, there are a few categorical variables, okay? I think I forgot to mention that. Let me just go back. Yeah, so when you do this train.info, that will tell you how many variables are float, how many are integer, how many are object. Object is basically category. So there are 8 variables that are categorical, and other all variables are numeric. So coming back. So for categorical variables, it is also important to encode them. Like when I say categorical, it is basically text, right? That this is maybe this is cardiovascular or this is whatever. I mean, these kind of terms will be there. So you have to define like, okay, cardiovascular may be representing as 0 or something like that. So you have to encode it into numbers because your model is understanding only numbers here. So that is missing values and encoding. These are 2 things that you have to perform next. So these are different categorical variables, the 8 different categorical variables. You have put it into a separate list. And for each of the categorical variables, you've seen how many different categories are present. And also, so how to treat with missing values. Before you encode them, let's first treat them. So one thing is you can use a simple imputer, which is there in sklearn. over here. You can see, you can read about it, what it is. So it's basically, it will help you fill in the missing values. So you can define your strategies over here in the parameters. Like if it's mean, then it will replace the missing values with mean of that particular column. Median or most frequent means that it will replace the missing values with the most frequent value appearing in that particular column, and so on. So mean cannot be used for categorical variables. It can only be used for numerical variables. So most frequent can be used for both numerical and categorical. So you have to take a call here that how do you want to go about treating the missing values. So there's one thing which is like a homework. You have don't go by what I have done, because I've just done it for telling you what is the next step that you need to do. I've just done it like for all the columns. I've gone with the most frequent thing, that whatever is the most frequently appearing value, fill the missing value with that particular value. But don't go by this. Separate out your numerical variables and categorical variables and treat them separately. And one more thing that you can do is for categorical variables or even for numerical, see its correlation with the target variable, which is the hospital death. And like you can separate out another, like you can go one more filter down, that whatever are 0 hospital death, say the mode or mean in that particular category, and substitute the mean, missing values present in that particular category with this value. And for the ones which have hospital data as 1, see the mean or mode in that particular category and substitute with that. So these are different strategies that you can do. So these are all things which you can play around with. My job here is just to tell you what all things you can do. So this is simple, and simple imputer is very easy to do, because here you can just call the function and define the strategy. So separate out your numerical and categorical and separately treat the missing values is what I highly recommend you to go and do. After treating the missing values, you can do the encoding. Like for all the categorical variables, encode that. You can use this thing called label encoder. Okay, and after which, like the whole major, like now this has, like I think about 80% of work is done here. Now what you have to do is decide on which modeling algorithm you want to go ahead with, and the metric you have to use AUC metric, because that is what is this datathon going to evaluate you on. So that is predefined. So you only have to do is define your model. So what here I'm doing is I'm doing a decision tree. This is one way of doing it. You can go and check out different models. Decision tree was introduced to you by Shweta in the 3rd session. Have a look at it, what decision tree is. Or there are other ways also that you can go ahead with. So experiment with it. There is another thing called Cat Boost, which Usha had introduced you to. And Cat Boost is good because one task of missing value can be reduced there, because Cat Boost can deal with missing values on its own. But if you're going with any other algorithm, then you have to treat the missing values on your own. So have a like experiment with different models, because once your 80% of job is done, all you have to do is try different models out. So you can take your time on that. So yeah, now here, first of all, train test split. Or when your train test split, what I'm doing here is obviously we have a test data separately given to you. This train test split is to split the data into train and validation. Let me call it that way rather. So it's basically you're taking 80% of the data set and training the model, and the held out 20% you'll use for validation, or that's like a hidden data set. Like later on, you'll see, okay, now is it giving good results on this data set as well or not? Or here you can, that overfit concept comes. Is it like performing only good in the trained data set, and the hidden data set it's not performing good? That means the model has overfit. So all these things you can experiment over here. And then, so for modeling, it's very simple. You import the function, you initialize the function, and you fit it, dot fit. You provide the input and output to it. This is all the modeling step is. Like it's a 3-line thing. Whatever differently, if you're using logistic regression, import, initialize, fit. Three steps. So modeling, you can imagine, is just from the coding standpoint, it's very easy. Random forest you're using, again, import, initialize, fit. That's all. So that's that. And then when you predict, you have to just call dot predict, and you get the predicted values. Here, what I want to tell you, okay, I'll come to that particular part. Let me go to the metrics first. So AUC is a metrics, area under curve, that I think Shweta or Rinki, they had introduced these concepts. So we'll be going with AUC, and that is like we won't be using accuracy here since we are dealing with imbalanced data set. So accuracy won't really help here. We have to go with AUC, like true positive, false positive, all these things which are very important here, because when we are dealing with imbalanced data set, you can plot your confusion matrix and see. You can also obviously you can see your accuracy as well. You can see here my accuracy is about 87%, but my when I go and see this ROC, and then when I plot this ROC curve, if you remember, this ideally should have like the good result is when this curve is close to this axis, like it's like this, right? So that is when it's good. And now here my area under curve is just 0.64, which is not like a really good result, not at all good result, I would say rather. So even if my accuracy was good, my area under curve is not giving me a good result. So you can, this is what I kept accuracy over there just so that you understand that accuracy can be good, but because it's an imbalanced data set, it's highly possible that the ones, like, let me spend some time here. Okay, so it could be that you have like so many rows which are having hospital data 0 and only few which are having 1. So it's possible that the ones that are correctly predicted are all coming from the ones which are 0, and the ones who are incorrectly predicted, the maximum number of them are coming from the ones who are having 1. So here we're losing the whole problem statement, right? I mean, we want to predict the ones who are going to die. That is 1 is what we want to predict. So we want high accuracy happening in that particular part. So you see, that is why these confusion matters very important. Like go back to that that thing and have a look, because I don't have time to explain these concepts again, but I'm just highlighting the part here, that confusion matrix, why it is important to understand what is true positive rate, false positive rate, and all of that. So that is it. And obviously here, I was expecting my result to come very bad because I have not done the imputation well, and I've just used simply a decision tree. Probably some other algorithm can be good over here. And it's just a way to give you an approach. So take this as a baseline and build on this, I would say. And one last thing I'll tell you here is, because this is very specific to this particular datathon, is that this result that you're getting, this Y prediction, if it is 0, 1, your this submission is actually asking you for probability. Like, let me just go to this. Okay, so this data, the submission, sample submission. So when you're submitting, you have to only submit only these 2 columns, okay? One is the encounter ID, and the other is the diabetes, this thing. This is for this particular data, okay? For last year, it was, instead of this, it was hospital death. So what you want here is not 0, 1. Even though this is a binary variable, it takes only, it is going to give you 0, 1. But here they want this probability, that how much probability is it 1? Like 0.1 means it's just 0.1% that it is 1. Okay, so this is what they want. So which is why what you have to do is take this thing called predict proba. Predict proba, instead of predict, use predict proba, which is going to give you the probability. And this is going to give you 2 columns, probability of 1, that the output is 1, and the probability that the output is 0. So take only the I think the first is going to give the probability that it is 0, and the second is going to give the probability that it is 1. So take the second column. for submitting it. So when you submit, it's very simple. Just from the take the encounter ID, separate it out, and then take the target variable and just combine them together and submit it. Like the code is available over here. You can see that. Use predict proba. That's the important thing which I wanted to tell. That's about it. We can take questions. We have 10 minutes.
So anyone has questions, they can unmute themselves and ask questions. So Karthika, like, have you tried using a recall for this data set? Recall value for calculating like how good it is, the model?
I have so recall and so all these AUC, the access for AUCs, I think recall or something, no, true positive, something like that. So in that it's calculated. So AUC takes care of recall in itself. True positive rate and recall.
Okay.
These are the two different accesses for it.
Okay, thank you.
But yeah, I mean, I get your point. So separately understanding what is a recall value and everything. So all these spending time on those is also important. But AUC takes care of it. Yeah. I think for the certificates, please, I mean, I think we'll float. I don't know how do we manage, Julian. Maybe you can tell about certificate part. How can we? We'll come to we'll plan a system how we can distribute certificates and everything. We'll come to that, but we'll give you certificates for attending this workshop. Don't worry about it. It might take a while, but we will send the certificates. So that's about it. If we have no more questions, please, I hope this session was helpful in giving you the baseline to start from. I've shared the links and get started. You have 3 good weeks to work on this particular problem statement. And it's very similar to last year, which I have like covered it for you today. So spend time and see what are research that you can do and see unique things that you can make a note of whatever unique things that you're able to do. Okay, because you can make a research paper out of it, and you can the part 2 is the research paper part of it. So and please do apply. So I actually let me present the screen. Last thing here on their website, you go to their website and click on this take challenge, which will go to this particular form. So fill in here. I'm not sure why they are doing this, but you have to separately register here as well. So if you go to Kaggle and directly register from there and start doing, I'm not sure if they will be able to record you or not. So it's better that you do register here as well, so that you don't get missed out. Okay, so register from their website as well.
Yeah, thanks, Karthika, for mentioning that. We can share that link, Airtable link in our group as well. Right?
Yeah.
Also, everybody do make use of the WhatsApp group. If you have any doubts, feel free to reach out all of the 5 days. Everybody's within that group, and if there's something we can't answer, we'll get you in touch with whoever can answer that question. So make use of this opportunity. There are, I think, 130 people already in that group. I mean, not forming a team is it's one of the least concerns. Your main goal out of this should be, did I understand how to apply and use data science for any small data set at least. So make use of this thing, tell your friends about it, understand how to use statistics in a prediction scenario. This is going to help you even beyond this datathon. So stay in touch and make sure you guys use the resources that you have. Thank you for joining, everybody.
Thank you for joining.
And thanks, Karthika, for the wonderful session.
Thank you, Aksa.
Thanks, Karthika.
Yeah. Thank you, everyone. So we are giving you back your 5 minutes. And bye.
Happy weekend.
Happy weekend.
Happy weekend, everyone. Bye.
Bye. Oh, Karthika? Karthika, are you there?
She's frozen. Kya hua?
Maybe we can stay back and discuss few points if possible. Like Karthika paused.
Just left.